The Intelligent Taxi Hailing System, or ITHS, is a system for brokering rides between taxi drivers and spontaneous taxi users, or hailers. ITHS leverages emerging connected vehicle technology enabled by dedicated short-range communications, or DSRC. The system replaces line-of-sight street hailing with electronic dispatch through public kiosks and smartphone apps to reduce the time required to hail a taxi. Assume, for this scenario, that a hailer has used the kiosk to request a taxi. The hailing procedure works as follows. The kiosk relays a hail request to a back-end computer via the internet. This computer, known as dispatch server, is responsible for monitoring the region's taxis and attempting to match available taxis with hailers. The dispatch server receives continuous updates about each taxi's location from DSRC transceivers installed in the taxis. These transceivers, known as onboard units, or OBUs, generate messages about a taxi's current position and status every tenth of a second. These messages are received by a service area's roadside units, which route these messages to the dispatch server, which use them to update the taxi database. When a dispatch server receives a hail request from a kiosk, the server chooses the closest available taxi from its database and sends a hail request to the roadside unit closest to the taxi's last known location. If a taxi is not in the roadside unit's service area, the server sends the request to all roadside units within a given radius of the taxi's last known location. The server expands the radius of roadside units transmitting the request until it either receives an acknowledgement that the message has been received, or it reaches the maximum search radius. If the taxi cannot be found, the server attempts to find another taxi close to the rider, and the process is repeated. The roadside unit closest to the taxi forwards the ride offer to the taxi's onboard unit. The onboard unit relays the hailer's request to a driver vehicle interface, or DVI, in the taxi. This DVI will typically be the driver's smartphone, the driver's tablet, or a built-in console in the taxi's dashboard. The onboard unit communicates with the DVI via Bluetooth. The DVI displays a hail request and gives the driver the option to accept or reject the request. The DVI relays the driver's response to the onboard unit, which forwards it to the roadside unit closest to the taxi via DSRC. The roadside unit relays the driver's response to the dispatch server via the internet. The dispatch server updates its taxi database. If the driver declines the request, the dispatch server tries to offer the request to other taxis. If subsequent efforts fail, the dispatch server notifies the hailer via the kiosk. Assume, rather, that the driver accepts the hail request. The dispatch server relays the acceptance, along with the taxi's estimated arrival time, to the kiosk. Meanwhile, the dispatch server gives the taxi driver the kiosk's location. The driver proceeds to the pickup location. If the hailer decides they no longer want the ride at any point during the process, they have the option to cancel. Should the hailer cancel before the rendezvous with the taxi, the dispatch server is updated and the taxi driver is notified. The taxi driver also has the option to cancel a ride. If this occurs, the dispatch server automatically tries to find another available taxi nearby. Assume the taxi picks up the hailer at the kiosk. The driver confirms the pickup using the taxi's DVI. When the driver drops off the hailer at their destination, they confirm the drop-off using the DVI. When a server receives the drop-off confirmation, it makes the taxi eligible once more to receive hails.